Hello, hello. Ακούμε, εντάξει. Ωραία. Hello, hello. I'm very happy to be here. I mean, this year's lineup is excellent, and I'm very excited. And I generally love tech conferences, but not just for the tech. What I really like, I mean, my really favorite thing is to find out how companies really use tech, what architectures they're using, what tools. But you know how most architecture talks usually start with something like this. This is the final grand version where everything is complicated, but it works. Everything makes sense. Everything is in the right place. Every tool, every pattern, they're excellent. And you're like, when you see that fully, well, duh, that was the correct thing they had to do. But it is much different when you're just starting. Back then, everything is an unknown. You have to make dozens of decisions, and there is so much tech out there that you, of course, do not have the time or the resources to explore all of them. And honestly, this is also how we felt when we were starting this road ourselves, and we had to unlock this map piece by piece. I am Spyros Angelopoulos. I'm an expert architect at XM. I mainly work with Java and Spring in the backend, but I also do a lot of infrastructure and system design as an AWS solutions architect. And I've been through various teams and roles in the company, so I've had the chance to see our ecosystem and our architecture evolve from many different angles. And today I'm gonna guide you through this map that we have been building. This is not going to be a deep dive. This is not going to be a Kafka tutorial. We will cover a lot of stuff, but we will keep it relatively high level, so don't worry. I will start with the problems that made us look into asynchronous architectures, the tools that made it possible for us, and I will finish, of course, with the lessons that we learned along the way. And the goal for today is so that you get a clearer view of the whole tooling ecosystem and the architecture, so that when it is your turn to make decisions, that you will have a head start. For those of you that do not know who we are a global online trading platform. Our customers can trade Forex, stocks, metals, and various other financial products 24/7 all around the world. And we're also the masterminds and the creators of trading.com, which is our US specific brand. We have been in business for more than 15 years now, and we have been growing exponentially, doubling almost every year. But the thing is, when you are getting bigger that fast, the challenges and the problems grow with you, and sometimes even faster. So like 6, 7 years ago, we kicked off a massive tech transformation. We were splitting our monoliths at that point that we had. We were introducing dozens of new microservices, dozens of new services, and we were shifting everything from other cloud providers and real machines to AWS. At that point, our infrastructure looked something like this. Most of our microservices were inside our Kubernetes cluster managed by Amazon. We had some applications in ECS, which is Amazon's container orchestration service. Few services in EC2. These are virtual servers in AWS. And to keep things spicy, we also had some few but critical applications in another cloud provider at that time. And since our services mostly communicated through REST, they were very much tightly coupled. That means that changing one meant that we had to worry about all the others almost. If one of them was failing or if it was slow, this cascaded along the whole system. And of course, because we had all these different environments, it was very easy, some traffic spikes, to cause uneven loads between them. And it might seem simple in this diagram, but honestly, it usually felt like this. The whole system was very fragile, and it was evident that we need to find a better way to communicate between our services. We need to find out something that made the system more decoupled, more durable, and more scalable. Of course, that something turned out to be Kafka. Kafka is an open source distributed platform for real-time data streaming and event processing. This mouthful basically means that instead of having one service calling the other directly, it sends a message to Kafka, Kafka stores it, and then delivers it to anyone that wants to learn about it. So it's like moving from a phone call to a group chat. You just write something once, and then anyone that wants to read it can read it on his own time. Anyone that's interested can read it and act on his own time. So just the extreme basics. We have a producer that is sending a message to a topic. Topic is like a category. It's like a channel. The topic is split into partitions, and it depends on the key of the message in which partition it's going to go. Partitions are extremely important because Kafka guarantees the ordering only inside one partition. A single partition. The partitions are stored inside our Kafka clusters, in our Kafka brokers. We have the leader and the replica brokers with backups, and the consumers are reading these messages organized in consumer groups. And again, the partitions are very important because you cannot have more consumers in a consumer group than the number of partitions. I mean, these are the extremely basics. It's like describing a Formula One car like something that goes vroom, vroom, but it will suffice for what we will discuss today. The thing here is that now we have a system that is decoupled because producers and consumers do not know about each other. We have something that is durable because Kafka can store all the records and replay them on its own time, and something that is scalable because Kafka can accommodate by design, and especially due to the design with the partitions, huge amounts of data with ease. And we added Kafka in the heart or in the center of our ecosystem, and it quickly became the central nervous system of the whole architecture. We have no more tight coupling between the services because they do not communicate directly. And we can now easily change one and deploy one independently without having to worry about the others. That means that also if one fails, this does not cause a cascading failure inside our system. And Kafka can absorb any traffic spike until all the different environments have been scaled out accordingly. And the most important thing is that we have now this separation between producers and consumers of data. And this shift is what made everything that we will discuss about today possible. And once you have Kafka in place, you can also unlock other very useful architectures as well and strategies. You can have, for example, event sourcing. So instead of storing a snapshot of your data, you can store all the different messages, replay them, and get your data at any point in time. For example, we are storing all the trades of a trader, and then we can replay them and reconstruct the state of his account. We are using Kafka, and we have been using Kafka quite a lot, more than 350 topics, 230 billion messages, and this is some months ago. 3 such brokers, 4 different environments, so you can understand that we have been using it a lot. And the main tool that gave us this possibility to use Kafka so extensively and so effectively was Spring Kafka. I mean, we are a Java shop, we are a Spring shop mainly, but Spring Kafka was not chosen by accident or by chance. Spring Kafka can simplify the integration of Kafka inside your application. The developers can write less boilerplate code, and they can focus their mind and their effort on the business logic rather than managing the low-level APIs of Kafka. Extremely easy to configure your Kafka listener, especially with configuration properties. The code is minimal. Extremely easy to configure your Kafka producer and produce and send messages. Here, for example, with Kafka template. And very, very flexible error handling. Obviously, do not try to read this. I don't think it's readable. But see how in less than 50 lines, half of which are comments, you can have different retry mechanisms for different errors. You can have dead letter topics where you are sending your failed messages. You can have different retry mechanisms depending on the exceptions that you are throwing, and custom recoveries. And the powerful thing here is not that you can do this thing, but that it is self-contained. This code, this error handling ends here, and the rest of the code is not polluted anymore by low-level Kafka error plumbing. You do not have to sprinkle try-catch blocks everywhere inside your business logic. Spring Kafka also supports transaction management in both producer and consumer. This means that the producer can send multiple messages, all or none, and that the consumer can receive a message, process it, and send another message in one atomic action. Extremely important for us and our many microservices where we want this propagation of transactions. And with a single property change, you can have multiple in parallel listeners without having any manual thread management. Important because we often forget that not everyone lives inside Kubernetes where you can scale out your application and have multiple instances just because you want a couple listeners more. Testing with Spring Kafka, very smooth. You can basically have two different strategies. You can either use embedded Kafka, and this is mainly for lightweight and fast tests. You can spin up an embedded, of course, broker inside your JVM without any kind of Docker, any other dependencies. Or you can go the real way, the test containers way, where you have a real broker in a Docker container, and you can have tests that are very much closer to the real environment that you would have in your production, and configuration much closer to that. You can choose whatever you want. We are using both actually. So yeah, with Kafka, we unlocked a huge part of the map, and Spring Kafka quickly became our bread and butter. But we kept on finding some problems that required different approaches. We had to explore some new tools, and we had to expand the map a bit. As more and more of our services were producing different messages into Kafka, we had this common need where we wanted to combine various different messages, related of course, and emit a single meaningful one for them. Or we wanted to filter, aggregate, and enrich these messages as they were flowing inside our system in real time. For this, we turned to Kafka streams, which is essentially functional style programming over Kafka messages. This means that you are listening in this stream of Kafka messages. You can group them, you can filter them, you can enrich them, you can do any other thing that you would do with a normal Java stream. See here in this example, let's imagine that we have a topic with all the trades. If we group them by key, by currency, we now have all the trades by this currency. We can aggregate the volume and push them to a new topic that has the total trade volume per currency. Or we can filter by amount, just keep the big trades and push it into a topic with high volume trades. And for those of you that you have been checking this code snippet, of course, you see that it is sort of understandable if you have been doing functional programming. I mean, that topology was quite simple. This is an abstraction of a real one that we use in production. We use dozens of them like this. But the killer feature that we really like is the state stores that let you persist local critical intermediate data without the need of a database. because they're backed up by Kafka. This basically means that you can be running your Kafka stream in your Kubernetes pod, and if that pod restarts, if your application restarts, you will continue processing with minimal data loss. And let's put our Kafka Streams applications in this map that we have been building. They live inside our Kubernetes because they are real Java apps. As we said, to summarize, Kafka Streams, lightweight, you do not need something else. It's just inside your application. They come with the scalability and the fault tolerance of Kafka. It is easily to have exactly one semantics. That means that even in case of errors, you're not gonna get multiple messages. We talked about state stores and why we love them. And of course, it's written in Java and we love them as well. But at the same time, as with everything that is streaming and everything that is functional, it has some learning curve. Debugging is a bit more difficult, and okay, we are Java developers. What if we were not? It wouldn't be that easy to do this with this tool. This pattern of aggregating and correlating messages was something that we had to do often, and usually Kafka Streams was the right tool. But we had some cases, some corner cases, where Kafka Streams could not handle this. For example, we had this application that was pumping millions of messages per minute to Kafka, want to calculate some delays and build some nice dashboards and alerts. And the problem was that in order to do these calculations, we had to do some very complex joins across time with very complex sliding windows, and while at the same time handling the back pressure of these messages. And for this, we turned to Flink, Apache Flink. Flink is a distributed stream processing framework for large-scale real-time data. Basically, this means that you have complex event-driven pipelines. You put your data inside the Flink, and there you can process them in streams in parallel while supporting windowing, watermarks, back pressure, and in cases like this. Also, they are written in Java. You need to write Java in order to use it. We integrate with Kafka. It's not that it can be used only with Kafka, but we use it with Kafka because that's where we get the messages from. And we use once again, the managed service of Flink managed by AWS. What we have done, as I described, is that we are getting the messages. We have Flink connected to our Kafka cluster. It gets the messages. It does its magic and the processing, calculates our delays, stores them in a time stream database. This is a time series database by Amazon. And then we have our dashboards that are querying this database. This is actually the real Grafana dashboard that we were building with this solution, and at that time, it was a very critical core component of what we were trying to build. You might think that Flink is a bit exotic, but honestly, if you start having these problems with very out-of-order event streams, it's one of the first tools that you will find that might help you. And with good reason, it is very, very powerful. And for us that we are using the managed version, the auto-scaling and the throughput that we get is a godsend. And it also has a nice web UI where you can see your parallel jobs that are running. But it is also very complex. It has a steep learning curve. And to give you an example, the team that is handling our Flink system has some developers almost dedicated to this. And when they need to onboard a new person, it takes a lot of time. And if you're using the managed version, it can get expensive quite easily. So my recommendation is, yeah, Flink is quite powerful, but make sure that there is no simpler tool for your case because it requires a lot of investment. On the other hand now, we had some very simple stuff. We want to do some very simple stuff. We didn't want to do any joins. We didn't want to keep any state. And honestly, it felt like an overkill having to run an application just for this thing. For example, we want to add some headers and some metadata for compliance. We wanted to trigger some alerts and some simple side effects inside AWS. And we're like, OK, there must be a simpler way to do that than writing a full application just for that. And for that, we turned to AWS Lambdas triggered by Kafka. So Lambdas are a serverless compute service that scales automatically without you having to worry about infrastructure and executes code in response to events. So you have Kafka that is excellent for event streaming, Lambda that is ideal for event processing, and together you have something that with low effort gives you maximum flexibility. Of course, you get the serverless scalability of Lambdas. As I said, you do not have to worry about your servers, your provisioning, your infrastructure. Once you're inside the Lambda, you can do anything in AWS. They're first-class AWS citizens. They are pay-per-use. If you do not use them, you will not pay for them. You can write Lambdas in a few languages, which is always a good thing. And the configuration is actually quite easy for this solution. It's just a page of drop-downs where you can put your properties, your topics if you want batching, and it's simple as that. Of course, you are going to get the concurrency limits that come with Kafka and partitions. You will only get one instance of Lambda per partition. And it's not meant to be a Spring Kafka or a Spring or a full Java application alternative. It's just for something extremely slow. Sometimes, if you have been writing Java Lambdas, you have seen this cold start problem. The first time a Java Lambda starts, it is a bit slow. But AWS has solved that mostly with Snapstart, which is actually a one-click solution in order to bring down this startup time from seconds to milliseconds. It's like Java Crack if you have heard about it. Some example use cases that we did, some simple data enrichment before storing into a NoSQL database, and updating some AWS dashboards with events that were coming from Kafka. Simple stuff, simple stuff. But the more that we were building, more and more and more, we were keep coming on in this pattern, take from system A, put into system B, take from system A, put into system B. And for us, this mainly meant take from Kafka, put into Oracle, because we are also heavy Oracle users. And it didn't feel like building and scaling an application. We didn't feel like running Lambdas just for this thing. Even a Lambda was like too much ceremony. It's just simple plumbing. We were wondering, is there a simpler way to do that? Is there a way that we can just define what we want to do and just have something else take care of this? Well, actually, this something exists. It's called Kafka Connect. And it is a tool that moves data between systems through your Kafka cluster. You do not need an application. You do not need a Lambda. You have source connectors that are automated ways to get data in your Kafka cluster, sync connectors that are automated ways to get data outside of your cluster. And usually the only thing that you need to write is some configuration here. You can write some simple converters if you want to, though. You can do some simple error handling. And we use the managed service once again. The open source community has a lot of open source connectors and sync connectors, but you can always write your own if you do not find something that fits you. And this is our solution. We have Kafka Connect running inside our Kafka cluster with a Oracle sync that is sending data to Oracle. And we had this custom integration with Secrets Manager. That is where our keys for Oracle live. And we needed to integrate with this in order to be able to talk with our database. Kafka Connect promises a minimum code integration, and honestly, once it's wired up, it just works. It has amazing scalability and very high throughput, at least for us that we use the managed version. But we also had to write some code because we are using Secrets Manager, as I said. We are using also protobuf, which is a serialization, a special serialization protocol. So, and I mean, okay, it was some simple Java code, but what if we were not Java developers? It's also not extremely popular, so you might run into the occasional bug. And at the end of the day, if you do not find something supported out of the box from the open source community, are you going to write your own? And if so, when does this promise of no code start to fail? And now let's go to a topic that is very dear to my heart. When we are adding new tools, it's very easy to be like, ooh, shiny, let's dump it into our stack. And then let's forget about the developer. It's not just a matter of does it work, but it should be a question of does it make writing code easier? Does it make debugging easier? Once it is live, does it help me maintain and monitor my system? If you do not tick all these different boxes, this tool, this architecture, this whatever is not helping. It just adds more complexity. And it is exactly the same with Kafka. When you introduce Kafka inside your system and you have many applications sending data, it is extremely easy to lose track of your system. It is very, very easy to lose track of who's producing what, who is listening to what flows inside your topics, and why. We use 3 tools to mitigate that. We use Terraform, Grafana, and Kpow. Terraform is a way to manage your infrastructure as code. So basically, everything infrastructure is translated and created by code. We use it everywhere. And with Kafka, it's exactly the same thing. From creating a full cluster to creating a single topic, everything is done through code so that we can have visibility, who did that and why, so that we can repeat that, so we can roll back if something goes bad. Okay, Grafana, good old Grafana, we all use it, we all love it. But what I wanted to show you here is that once you start using Kafka, you also need to add your Kafka metrics inside your application dashboards. This is a real application dashboard of a real production application where we have added Kafka-related metrics because you can no more debug and monitor your application without debugging and monitoring your Kafka. Kpow supercharged the dashboard for your Kafka cluster. You can check everything from producers, consumers, Kafka Connect, topics. If it is lagging, you can also query your topics in real time. It's like having Kafka superpowers. There are many tools like that. We just happen to use this one. But I cannot stress how important it is to be able for every developer to answer and know what it is inside the topics, who's producing what, who's consuming what, how the system works, and instantly, not with, I will investigate and it will take me a day. We didn't used to have this, and once we added that was like a night and day kind of situation. So to summarize, we added our Kafka cluster in order to decouple our producers from consumers. For streaming data, Kafka streams inside our Kubernetes cluster. For corner cases and for very out-of-order messages, we added Flink. For simple stateless stuff that live inside AWS, Lambdas triggered by Kafka. And last but not least, for data plumbing, Kafka Connect. But of course, the architecture is never stale and never stops changing. A few months ago, we migrated from Kafka managed by AWS to Kafka managed by Confluent because we wanted better scalability, better visibility, and they also support schema registries better. It does live inside AWS still, but it is managed by Confluent. And of course, the question is, have we learned anything? The main point that I'm trying to make here today is not that you have to be exotic in your choice of tools. but that you have to be pragmatic and realistic. We are not building a tech museum. You have to be able to take into consideration the learning curve of a new tool, like with Flink or with Kafka Stream. You need to be able to balance the complexity and the flexibility of that technology, like with Lambdas and Spring Kafka. You need to take into consideration the cost. And you should never, never forget about the developer experience, because at the end of the day, we are developers. Of course, there's no fits-all solution. What worked for us might not work for you, and of course, vice versa. And you need to remember that the right tool and architecture for your system is not just a matter of technology, but it also reflects the company structure, your team's skills, and also the business constraints. And as architects, having to balance and make the correct compromises is the most important and the most difficult thing that we have to do. A well-designed, event-driven, asynchronous architecture will behave just as well as a synchronous one in ideal scenarios. But when things go wrong, and they will go wrong, it will outperform the synchronous one because it is more resilient, more scalable, more fault tolerant. So I urge you to start designing systems that are asynchronous first and make the synchronous just an exception. If you are a Java developer, you will have a great time. Kafka is an excellent choice for Java developers. We saw that the ecosystem and the tooling is amazing. Most of the features arrive first in Java Kafka clients, and of course, Kafka is built in Java, which makes it easier for us. I'm not saying that you will have to debug Kafka, but the couple of times that we had to do that, we were comfortable doing it, being Java developers. I'm also not saying that if you are not a Java developer, that Kafka is a bad choice for you. Actually, we are a polyglot company, and everyone is using Kafka, and everyone's having a good time. But if you are a Java developer, you will have this, first-class, extra legroom kind of experience. You heard me talk a lot about managed services. Almost everything that we are using is a managed service. And I really suggest that you also try to do that as well. For Kafka itself, for your Kafka cluster itself, but also for your other solutions. Mainly for two reasons. One is that while you are trying to shift from synchronous to asynchronous architectures, you will have various headaches. And you do not want your system maintenance to be one of them. And also, if every time that you experiment and that you consider a new tool, a new idea, if every time you need to also take into account planning, provisioning, maintaining, updating a new system, most probably you will talk yourself out of it. You will go with the usual way that you have been doing things, and you will never find out if that tool, if that idea was actually excellent for what you wanted to do. The path to event-driven bliss is going to be long, and you will need every weapon that you can get. So please equip your developers with all the monitoring and the debugging tools. Kafka needs to be a layer that helps you, that decouples your services, and not something that adds extra confusion. And I will say it once again, if you are switching to these architectures, you need to make sure that anyone can instantly answer what is running through your Kafka topics, who is producing, who is consuming. I know that I have been sounding like a Kafka salesman, but honestly, Kafka is not the only way to do event-driven. And sometimes, actually, it's not even the correct way. Sometimes you just need a queue, not a topic. And queues really are fine. Queues are excellent for specific use cases, like task distribution, for example. We use some queues. We use SQS, ActiveMQ, RabbitMQ in smaller cases, but we didn't have a lot of time to go into it. But to show you how important and how useful queues are as well, if you are in the latest Kafka version 4.2, I believe, we have a great new tool called Share Consumer API, where you can have a topic working almost as a queue and as a topic at the same time. I think now it's available for the Java Kafka clients and not for the other languages. I have hinted about this a lot, but did not go into details because honestly it deserves a talk on its own. And actually, most of the stuff that we talked here about deserve a talk on their own. The delivery guarantee of Kafka is at least once. This means that in rare occasions, you will have messages delivered more than once. And these rare cases are not that rare. They will happen. They will happen, and you have to take them into account. It is possible to make Kafka work with exactly one semantics. There are various strategies, but they are a bit complex and we cannot go into much depth. But my quick suggestion is to embrace this, let's say, limitation, to embrace the at least once. And do that by writing idempotent consumers. That is, consumers that even if they receive a message twice, they will have only a single outcome. I have left the, let's say, least sexy one for the end. Event-driven architectures and Kafka in particular is quite a vast topic. It's quite complex. And if you go into it with just superficial understanding, you will make mistakes and they will cost you in some cases. So before starting this journey, take some time and invest some time in educating yourself, in educating your team. Hopefully, I mean, the good news is that now Kafka is an industry standard. Confluent has excellent resources. Spring Kafka has amazing documentation. And we can always suggest the Kafka's Bible. And to do some shameless plug, also engage with the community. I'm also co-hosting the Athens Java Meetup community, where we often talk about event-driven architectures. You can see Victor Gamov here from Confluent. And we would love to have you with us. So if you are already building your event-driven world, good job. Hopefully, I inspired you to experiment with new tools and new approaches. The ecosystem of tooling out there is vast, and it can take you with the correct choices to your next level. On the other hand, if you are just starting out, I really urge you to take the leap. Event-driven architectures honestly can transform your system, and you will feel the difference in your everyday life. The quality of development, the quality of bug fixing, the quality of debugging and monitoring will improve massively. Hopefully today I helped reveal some corners of the map. So now that you feel a bit more confident making decisions regarding this. And please remember that the correct tool is what suits your team. Pick the tools that fit your team and then expand this territory step by step. I am Spyridon Angelopoulos. Thank you very much.